Okay, we have a circuit here, and I want people to be able to calculate the equivalent resistance for this circuit, or for any circuit for that matter. But if you can do this one, you're probably going to be able to do all circuits with just resistors. If we're getting different capacitors kind of things in there, it gets a little bit more complicated because that starts depending on your AC current, your frequency stuff. But just these kinds of things we should be able to do. It requires a little bit of practice, and it requires a little bit of planning and insight when you're doing this. I'm going to say that all these resistors are 8 ohm because speakers are often 8 or 4 ohms. Just to make it a little bit more realistic, we're going to use 8 ohms. So I want to know the equivalent resistance, which I call RV, for vervangingsweerstand. So how do we go about this? Well, I'm just going to use a couple of different colors to make it a little bit easier for ourselves. What you first have to do with these kinds of circuits is really understand what is parallel and what is in series. You really should be able to follow these lines and see where they come together and where they split. Now I can see a group here of a parallel part of the circuit. I can see here some series part of the circuit. All right. I can see another parallel part of the circuit. Over here. But within that parallel circuit, I can see another parallel circuit right here. Now these two here are in series. This parallel circuit is in series with that one. And these three are all in series. So you should be able to recognize what is in series and what is parallel. Now you can also maybe recognize that it has a few different levels. If we look at the whole thing, these two parallel circuits are actually in series as well. So we have some groups embedded within groups. So this is the whole group. And then within that group, we have one group, which is a parallel. And within that parallel, we have series. The other group is more complicated. It is a parallel with 3 in series. And these series resistors are parallel with 1 resistor and another parallel group, which consists of 2 series paralleled with 1 resistor. We need to start from the inside, all the way inside the groups. So we need to find out what the smallest group is and start from there. Because what we can do is we find the equivalent resistance, and then we can just act as though this becomes 1 resistor. And then if this is 1 resistor, we can just say that we can add it to this resistance because, we're in series at that point. This is in series with this whole part of the circuit. So we could just add them up. And when we have these added up, this part of the parallel circuit, we can then put it in parallel with these 3 that are in series. And then we'll have this whole thing, and we can just, replace it with one resistor. And we do the same for this, and eventually you'll just get a circuit that is actually just like this. So we're going to replace all these resistors, theoretically, not actually physically replace. We're going to theoretically replace all of these resistors with another resistor. Now, we got to do that mathematically. So let me get my cleaning cloth thing. It's not perfect. Okay, there we go. We got to do this mathematically, and we know the two equations, hopefully. R1 plus R2. Something like that. And parallel is 1 over R1 plus 1 over R2 plus 1 over R3 and so forth is 1 over RV. This 1 over RV is pretty important, and we'll see that in a little bit. Let's dive right in. We'll see here these two are in parallel with this guy. Let's put these two series together. So we have 8 plus 8 is obviously 16 ohm. So these two together are 16 ohm. They are in parallel with this other 8 ohm resistor. So we gotta say 16. We gotta do 1 over 16. This one, these two. Plus 1 over 8 is 1 over RV. This comes out as, let me see, 0.1875. But that's 1 over RV. I don't want to know 1 over RV. I want to know RV. We're going to replace it with a resistance. We don't want 1 over the resistance. So we got to do 1 over this number is 1 over 0.1875 is 5.33 repeating. So we have found the equivalent resistance of this group. I just marked at the corners there. This group is in parallel with this other group. But first, let's just say that this little group here is our RV1 is 5.33 repeating, because then we can make a little bit more space for the rest. Now we can actually do this whole thing in one go if we want. We can also add plus 8 to this 5.33 because it's in series with this resistor here. So we can add 8 here, and then we would have this group, and then we'd have to put it in series with this. But I'm going to show you what it would look like if you would do such a thing in a speedier fashion, although it would look a little bit more daunting maybe, but this is what it would look like. Well, RV is 1 over something. And why this 1 over this whole thing? Well, at the end of our last thing to get 5.33, we had to do 1 over 0.1875. So I'm kind of already going to do that right with my equation at the start because I'm lazy like that. I don't want to type any more than I have to. So I'm just going to put it right there, up there. So everything we will write down here will already have that component in it. 1 over something. Okay, and let's start with these boys. We have 3 times 8. 1 over 3 times 8. And that's these boys. Oh, that doesn't... Oh, he really doesn't like that, huh? Yeesh. Shouldn't write too much on this. It's going to get dirty. 1 over 3 times 8. Plus 1 over 5, 3, 3. And then you would say, maybe you would think plus 1 over 8. That's not quite right. If I did that, it would insinuate that there was an extra group of parallel. It would say that there were 3 lines, but honestly, there's just 2 lines. We made this thing into one resistor, and we're just adding this one in series. So what we actually have to do is say 1 over 5.33 plus 8. Because that's one line. Every line in a parallel circuit gets one of these things. So we have just 2 lines here, this one and this one. So we're only having 2 of these. And if you would calculate this part, this whole thing, put it all together, you would end up with RV. So let's just do that right now. And we end up with 24.075 and some stuff behind it, which I don't really care for. So that's our RV equivalent resistance of this thing. Okay. Well, if we want to know the whole thing, we still have to do that part. But let's just say that this is 24.07. Well, that's going to be in the way if I put it there. $24.075. You can, of course, do this with smaller steps. I just want to show you what it looks like if you use a little bit of a bigger step. Still have to do that part, which is 8 plus 8 and another 8. It's the same thing as this, actually, if you would look closely. 8 plus 8, 16. Was that 0.1875? I believe it was, which would lead back to 1 over 5 is that same 5.33 ohms. Sometimes you don't need to do much more because you've already done a similar circuit, and it's right there. It's the exact same. So this one and this one together, because these 2 parts are in series with each other, is obviously 24.075 plus 5.33, and that equals 29.405. Now you might go and do this, throw the towel in the ring. But don't do that. This seems complicated, but even I can do it. And I'm kind of a dum-dum, actually. I might seem smart sometimes, but, I just practiced. I had to do this a lot of times. And honestly, you're going to have to do this a lot of times too to get this to feel normal to you, to really see these groups of that. But it's important for you to be able to do this. So you're going to have to practice this. And I promise you, you will be able to do this because eventually, you'll get it. And it's an important skill for anyone doing stage technician stuff, I suppose. If you're wiring your speakers, 8 ohms, if you're wiring speakers, and this is not a very unreasonable wiring schematic for speakers, I don't believe. You gotta know what you're doing. You gotta know what your final resistance is, because you want that to work with your mixer, and you don't want to give it too much signal or too little, or you don't want to overload your speakers, because that's dangerous, and you don't want to damage your speakers. I'm going to give progressively harder schematics for you to work through, and I will also provide the answers and steps you take to do that.